Hello everyone, my name is Vikram Poth and your EV battery expert from batteryline.com and also your host for today's webinar. So today's webinar is about conveying and handling systems for cans and lids in can manufacturing lines as well as conveying and handling system in cell manufacturing. So we are today joined by our expert Mr. Rene van Kralingen, who is the project director from Canline, where Canline is an international specialist in providing turnkey and turnkey handling and conveying solutions for metal rigid packaging. Canline already installed their lines with proven market-leading solutions and is actually helping Giga Factories to scale up and also to shape the battery industry when it comes to can and cell handling solutions. So, Mr. Rene, we request you to share more about yourselves and Canline to our audience.
Yes, okay. Thank you, Mr. Vikram Paul, for giving me this opportunity, of course. And as you mentioned, I'm working for the company Canline, based with the headquarters in the Netherlands. And we have also a location in the US. Myself, I'm responsible for project management, so I'm involved in the execution of the projects, including the installation at our customer sites worldwide. And next to the execution, this was this webinar about, I'm involved in opportunities for the battery market. If you're looking at these slides, you see we are experts in air and magnetic handling solutions. We have already more than 40 years of experience with references, global major OEMs and can manufacturers. We have strategic partnerships to become a sustainable industrial leader. And it's Canline, but we are part of something bigger. We are part of the Xano group. If you're looking at our installed base, you can see it's two areas. We are really based. We have an installed base in Europe, and we have an installed base in US. We have installed base also all parts of the world, but this is our main focus. So in Europe and the US, and every dot we have some equipment with our main customers. And if you're looking at our product portfolio, we are aiming for the beverage market, for the can and the lids. And we are aiming for the food market, 2 pieces, 3 pieces, metal packaging. And beside that, that's the food and beverage. We also looking into the battery market. So Canline is known for its expertise in handling solutions for the rigid metal packaging for the food and the beverage market. We have an installed base worldwide. And if you're looking at batteries, it looks a little bit different than food and beverage markets. But if you're looking at this picture on the right side, you see a can with a logo from the battery. So with some creative ideas, you can also see a battery in the can. So looks like different market, but it's not. And I will explain that a little bit further during this webinar. Some proven applications, what we have already in EV batteries, fully automated line, high quality, continuously single and mass flow, buffer capacity to maximize the outputs. And we have a modular approach, limiting ramp-up times. High manufacturing speeds we have, maximizing the output. If you're looking at cans, we can up to 3,800 cans a minute. And if you're looking at the ends or the lids, up to 12,600 lids a minute or even more than that. And of course, we use that, we transport those products with our air and magnetism expertise. So our mission from Canline is to be the world leading specialist in rigid metal packaging conveying equipment and the most sustainable partner of choice by offering our superior technical solutions. We do this by handling solutions in the food, as explained, beverage, but also the battery industry. What we're doing is we connect the machines. Canline has in the meantime already more than 40 years of experience in belt, air and magnetic handling solutions with references in all global OEMs and can manufacturers. We are located with the headquarters, as explained, in the Netherlands, in Eersel, and from there on we supply the machines worldwide. to all over the world, but mainly the focus on US and Europe.
Thank you very much, Rene, for the introduction of Canline. Coming to the first question of the Q&A session. So what are battery cans and how does the battery can manufacturing looks like from the start to the finish?
Yeah, there are several battery types. Looking in EV industry, we're looking at, of course, but also in energy storage system is an option. In general, three types of battery. We have pouch, prismatic, and cylindrical cells. These cells are combined in battery packs and stored, used in storage and in cars. The focus of Canline will be the cylindrical cells. Handling this is quite similar to that of cans in the food and the beverage. So if you're looking at this slides, you can see we can use our existing technology in the area of the can production of the battery. Starting from a coil with the steel material, we make the copper, and then with mass flow we go to the body makers creating the can, and from that part with single conveying again to mass conveying to the washer, and from there on you can go to the washer or the next step in the to the pelletizing or the next step in the process. Looking at the picture below on the left side, you can see the mass flow production, for example, from the cup. And you can see with the green arrow, we go to the single machines by using our magnetism in the belt. So for mass flow, you go to single lines. So Canline has the expertise to supply those conveyors between the cupper and the body maker and then towards the washer. So transport from there on will depend on the building, but can also be done with conveyors, elevators, etc. So in this part of the process, we see our large 40 years of experience come into place. So from coil until the can making.
Thank you very much, Rene, for explaining like how the can manufacturing looks like. So coming to the second question. So can you explain the different type of conveyors commonly used in Giga factories for handling of battery cans or cells and the respective advantages and disadvantages?
Yes, I can explain of course a bit. There are several solutions to connect the machines. If you're looking still at this flowchart, you can see two different types of belts. You have the mass flow and the single lanes. In both mass flow and single lanes, we use our magnet solution, and the cans from the battery are from steel, so we can use our expertise in the magnets for that one. The mass flow has the advantage that you can transport the cans in mass and with single lanes feed them into the machines, making the battery. This makes the controls more easy to develop and maintain the line. And based on our history and experience in conveying, Canline uses this permanent magnets in the system. In special circumstances, we can use both magnets, the permanent ones and electrical ones. We can use them in elevators, lower raters, overhead transport, and of course in a mass conveying. It will guarantee production requirements across a wide range of products, from low to high speed. And a permanent magnet system by Canline is very cost efficient because the correct magnet strength can be chosen. It's not causing unnecessary wear or power wastage, and the permanent magnet solution does not consume electricity or need any maintenance. And other advantages of the belt with the magnets can be that side wheels are not always needed, so you can skip that one for preventing damaging of the product, and changing to another format can be done without changing parts because you're holding the products with the magnets in the belt.
Rene, when it comes to mass conveying, what do we can expect? How many cans are running on the belt per minute?
It's depending how many of the body makers you have, but you can imagine if there's now in the slide you see 2 body makers, it can be up to 4, 5, 6 body makers, and each body makers can make about 200, 250 cans a minute. So you can imagine the mass flow, yeah, what is it, 1,000 cans a minute is easily. And if you're looking at the beverage industry, for example, what I said before in the webinar, it could be even going up more than 3,000 cans a minute.
Coming to the next question, what are the key challenges that I'll repeat again. So coming to the next question, what are the key challenges that the battery can manufacturers face when it comes to battery can handling, and how can they overcome these challenges?
Well, the demand for batteries is growing very fast, and the factories have a lot of effort, put a lot of effort to keep up with this demand. And looking at the growth in the battery market, what is it yearly? Double grow is not strange, and you're looking still grow until, 2030 for sure. And the battery market is growing more than double digit in, every year. So you see factories as 100 gigawatt hour. So large factories making a really enormous amount of batteries. And beside the challenge material availability to produce the batteries, the handling and transport to the factories will also be a challenge. Uptime and availability of the equipment must be on a high level. And the beverage market, more than 3,000 cans a minute are coming. And if you look at the lids or the ends of the batteries, it's can up to go to 60,000 lids a minute. So automation is a part of this success, as well as balancing the capacity between the different steps in the process. Mass conveying, 2 single lanes and accumulation conveyors are crucial to get an overall good line efficiency. This will help improve the quality, reduce the cost, and of course increase the volume.
Coming to the next question, Rene, what are buffer systems and its significance in battery can or battery manufacturing?
I don't want to call it buffer systems, since it could be connected to waste. If you have a lot of buffer, that's not doing anything. So what you're doing is you create independency between two machines in the flow between the two production steps. For example, what you show in one of the previous slides, you start with a coil of steel making the cups. You don't want to stop the machines downstream when you're changing a coil. They still need to produce. So you don't want to wait those machines to wait. The new roll is installed, and we can start again. So instead, you make sure you have some accumulation tables and overcapacity upstream to overcome this. This can be done, for example, with how we call a bi-die conveyor, a bidirectional conveyor, which is a wide conveyor which can run in 2 directions. Filling, you can do that during production, and you can empty it, feeding the products into the line during, for example, a coil change. You can, for example, you can hold about 10-20 minutes of cans on that belt, and when you do the coil change, you feed that back into the system so the machines downstream can still continue producing. So body makers can continuously run and will be independent of a coil change in the copper. So that's why we don't want to call it buffer systems, but it's more, create independency between 2 process steps that every machine can still do its running.
Thank you very much, Rene, for that answer. For what is the importance of buffer systems? So coming to the next question, we know that Canline is having expertise in conveying and handling systems for can manufacturing, but as well as for the cell manufacturing line as well. So when it comes to cell manufacturing, where in the line does Canline today provides its conveying systems?
I think I prepared a small slide for you, Mr. Vikram. So as you know, Canline, an expert in mass conveyor. So it means a wide conveyor. What is it, 1 to 3 feet or even a little bit larger, transporting cans in or without product carrier. And from the mass conveyor, we can divert into the single lines, feeding into the machines in a different process. Every battery can or lid is made from magnetic steel, and with magnets you can handle these easily. So using the mass flow, you can have a smaller footprint. So you would do this with single lanes, all feeding to one single machine. It gives more flexibility, and it gives you more output. In this picture, if for example, one of the welders is not running, you go to the left picture where you feed in the cans, the jelly rolls and the lids. You feed them in with the mass flow, and it will be guided to the sides and feeding in with a single lane to the welders. Mass flow going into different welders. If one of the welders for a reason is not working, it will go to the next one, to the next one. And in the end, you have a return loop, feeding back the cans into the system. So with this one, you have a very flexible system with a wide conveyor and very flexible where the cans should go to. So if one of the welders, like I said, not working, you can go to the next one, and it's automatically, and we don't need all kind of difficult, complex mechanisms, but we use our expertise in magnets for this one in the mass conveying. So limited amount of sensors, limited amount of pneumatic air, all those kind of handling solutions. So that's our really the strength in this kind of concepts. The feeding out of the magnets, feeding out of the welders, it will be feed back into the system. Also again on mass flow going to the next step, to the electrolyte filling example.
Thank you, Rene, for explaining where does Canline today provides its conveying solutions in cell manufacturing. But we would like to know more about product carriers and why there is a need for product carriers in battery cell manufacturing and conveying lines. Can you please explain more about that?
Yeah, well, each machine, of course, has a different step in the process. And putting the batteries in the product carriers, you can transport it easily from one machine to the other machine with all the same interface. Make sure the interface you can in the machines can all be, let's say, more or less the same. And also for track and tracing, you can put, for example, on the product carrier a barcode, so you can track it through the whole process where it is. And the carriers are from plastic and steel, and therefore the handling with that part can also be done with our expertise in the magnetism and belt. So the concept is the same. And beside that, if you put the jelly roll, the lid into the battery, you want to have a stable transport of the battery. And you use the product carriers also for that one. You don't want in the whole system that the batteries fall down, creating errors, creating waste. So the product carriers makes the transport stable, have a good interface with the machine, and beside that, it protects also the battery from damages not bumping against each other. So it keeps them also separated.
Rene, you said that it helps in interfacing in between the machines. Can you explain what is the meaning of interface?
Well, how to handle the product carrier. You have to feed it into a machine. You have to grab it, for example, to put the next step into the next step in the process. So the interface always looks the same. So it's always the same kind of product carrier. So you don't have to change the batteries from one product carrier to another type. So that makes it more simple. If you can hold the product carrier as long as possible, you have all interface with machine the same.
Mm-hmm. Yeah, thank you, Rene, for explaining in detail how does product carrier help in conveying of cells. Coming to the next question, so how does predictive maintenance and data analytics play a role in ensuring the reliability and uptime of battery cell or can conveying equipment in Giga Factory?
Yeah, as I mentioned, I think before, uptime is very important in the Giga Factories. So we are developing that part, and we have great ideas and opportunities for this. For all lines, of course, all production lines, but also, specific also for battery lines for sure. We don't want to produce any waste and don't have any downtime. Of course, downtime waste, it costs a fortune. And yes, dashboards we already have. And then you can see how the line is running now or in the past. We are developing, how we call it, a system like CAS AI, artificial intelligence, to predict what's going to happen and what can be done to prevent unplanned downtime. Of course, for that, data is needed to be available, but it's also a learning process. First step is to collect the data and make it visible on a dashboard. The next step is to find the correlation between the data and determine root causes of faults and make sure that it won't happen again. The ultimate step is to predict what most likely is going to happen and to be one step ahead. And this will all support the maximum efficiency of the line, the OEE, including a constant aligning between the data collection, operability, and of course, the ultimate goal of a self-supporting system in the future.
Rene, starting up a new line most likely always goes with a lot of starting difficulties. Can you share more about it?
Yes, indeed. It always goes with a lot of difficulties. And in this case, want to mention our digital twin, how we call it. Installing a new line and commission it costs a lot of time. And during startup of a new line, there's always some hiccups and waste you are producing that needs to be fine-tuned. To promptly prevent this as much as possible, of course. Preventing waste and preventing the time. What we do is we simulate the line first in our factory. We call this digital twin to be installed at the customer, and what we do in our factory. We make a digital software version of the line to be installed and tested in our factory. And this way we can optimize, for example, already conveying speeds, widths of the conveyors to make sure that the line is optimal for the production capacity needed. And to do that, we use both conveyor characteristics, but also characteristics from the product in our simulation. And we simulate our solution, improve the line functionality already without having the line physically installed at the customer. And the PLC, the software what we're using is the same what will be implemented in the end in the line. And this way we can already commission the line digital, minimizing the startup time at the customer. So I think now I'm the Dutch guy, you compare it with the Dutch Formula 1 driver Max Verstappen. So prepared a nice sheet for that one to explain it a little bit further. So if you're looking at the 4 pictures, and that's what I explained also what you can do with the line to be installed at the customer. You validate first the line characteristics, the circuit where you could drive on, how is the temperature and everything looking. Then you simulate things. How does it, in the simulation looks like, and so you try to optimize the data and the settings. And then you emulate the digital twin by pre-configuring the software and to allow for digital factory acceptance test. So you do the simulation, emulation, and then you do the digital factory acceptance test. And in the end, with the validation done and the simulation done, you ensure a much smoother and shorter startup process at the customer side. So I think you can imagine with these 4 pictures that we do that also, we can also do that for a line to be installed at the customer. So imagine you have to drive the race, so you have to start up the line without doing any simulation or data collection before. You can imagine it costs a lot of time, and therefore you create a lot of waste and sometimes frustration. Why does it not work? So we try to do a lot of things up front.
Yeah, it's very real that the digital twin is very important for making lines run before installation. So thank you very much for explaining that in detail. Coming to the last question of this webinar. So what is the biggest challenge while conveying of battery cells in a Giga factory? So how can we solve these challenges?
Yeah, biggest challenge. Of course, materials will be a big part of it when it comes to the volumes, because it will increase further and further. It will be scaling up traceability and the quality. From beginning till the end, it's a complex process. And also the batteries itself are still developing. So beside the machines, also batteries are still evaluating, developing new types, new features. So to have more storage capacity in the batteries, faster charging, etc. So in our business, for that we have to provide the right solutions to handle the increased capacity needed in a flexible way. So on a small footprint, to further economic produce these batteries?
We have come to the end of this webinar. In conclusion, we have gone through the challenges faced by can and cell manufacturers while handling and conveying. We have gone through the process of how can or cell housing manufacturing looks like. We have discussed what's the importance of predictive maintenance and data analytics for can and cell conveying equipment. In cell manufacturing, we discussed how cells are handled in cell assembly area on the product carriers, and also we discussed what's the importance of product carriers while conveying of cells. Thank you to our audience who are watching this webinar today. And if you have any questions and would like to know more about our partner Canline, you can directly get in touch with our expert, Mr. Rene, or myself directly to the contact provided over here. So we request you to follow us on our LinkedIn page of batteryline.com to get the latest updates about our partners and their expertise in battery manufacturing and recycling. Thank you once again, and see you at the next webinar.
Thank you, Mr. Vikram, for this opportunity and the introduction of Canline. Thank you.